In this video, we're going to consider two very special examples on indices. And in particular, there was one point that I made in a previous video where we're looking at the zero index law. And we said that anything raised to the power of 0 is equal to 1, except one special value, except 0 to the power of 0. Okay. In fact, if you were to type in 0 to the power of 0, we get a math error. Okay. Somehow it doesn't work. Okay. We can put negative 255 to the power of 0 and we get 1. But why, how come 0 to the power of 0 does not work? And another interesting example is one that uses a negative base. Negative 1 to the power of, say, 3 on 2. So this is a fractional index. Okay, so this is the fractional index law. Law number 6. Okay, so if we type in negative 1 to the power of 3 on 2, okay, so 3 on 2, we get a math error as well. Okay, so in fact, if it was to the power, just to the power of 3, that would work, in fact. But not to the power of 3 on 2. For some reason, again, we get a math error. Okay, if that was a positive number inside the brackets, then it would work, and you can experiment with that. To me, good mathematics is about asking those why questions. It's not, to me, it's just not sufficient enough just to say, well, okay, because I read it somewhere, or because someone told me that just to accept it as 0 to the power of 0 we can't do, or whatever, then that's good enough. If you want to become better at maths, this is one of my strategies, is you've got to start asking those why questions. How come? Why is this the case? All right, let's explore that. Let's have a look at 0 to the power of 0 and see why it doesn't work. So 0 to the power of 0, would you agree, is really, and I'm going to sort of invent a number here, is really just the same as 0 to the power of 1 minus 1. After all, 1 minus 1 is 0. I haven't changed anything here, have I? Okay. Now recall law number 2. When you divide two terms with the same base, and this is the base of 0, when you divide two terms with the same base, you subtract the indices. So this is really the same as, okay, 0 to the power of 1 over 0 to the power of 1. After all, we're subtracting the indices. Okay, 1 minus 1 is 0. Now, moving along the line, 0 to the power of 1 is 0. 0 to the power of 1 in the denominator is also 0. That's a division by 0, which cannot happen. Okay, that's undefined, and we can't work with that. So anything raised to the power of 0 will work, provided the base itself is not 0. Okay, when it's 0, what ends up happening is that you end up with a division by 0. Okay, and a division by 0, well, we don't know what to do with that. That's undefined. So therefore, 0 to the power of 0, we don't have a definition for that. You get a math error. If that was some other base, for example, let's say 2 to the power of 0, you could argue the same thing, which is to say, the same as saying, say 2, we can invent some other index, 2 to the power of 3 minus 3. As long as the two values here are the same, that's just the same as saying 2 to the power of 3 over 2 to the power of 3. 2 to the power of 3 is, that's, we have a value for that. That's just 8 over 8, and that equals 1. Okay, so anything else will work. Okay, just not the 0. Okay, so just wanted to explore that one a little bit further. What about the negative 1 to the power of 3 on 2? What's going on there? How can we get a math error with that one? Okay, so this is again another application of fractional indices. Okay, I'm just going to use a different board now. So, negative 1 to the power of 3 on 2. What's going on here? Right, this is the same as, okay, negative 1, okay, that's to the power of 3, okay, to the power of a half. After all, 3 times a half is equal to 3 on 2. Now we know what a half is, don't we? Right, a half is really a square root, it's a fractional index. Okay, that is also the same as reverse or switch the 3 and the half around. Okay, it doesn't really matter. It's multiplication. It's commutative. You can switch them. It makes no difference. That's the same as saying -1 to the power of half. Okay, all to the power of 3, which is the same as -1 to the power of 3 on 2. Now, using converting the fractional index into surd form, -1 to the power of a half, what's that? That's just the square root of -1. I've got a bit of a problem with this one. Square root of -1, well, that's a number that we haven't explored yet, and for those that end up doing extension 2, mathematics in year 12, we will explore this in a little bit more detail, but as it stands, we don't know what to do with this. Square root of -1, we have not defined that at the moment. Okay, so we have to count these ones out. Okay, so this one again will give you a math error. Okay, nice. I've got to be very careful what I say here, in that the square root of -1, we can't say it doesn't exist, we just don't know what to do with it, okay, for the time being. Like I said, those that do extension 2 in year 12, we do explore the square root of negatives. They do mean something, okay, but at the moment, we don't have any meaning or any definition for it as it stands, okay? And that is actually also a reason, when we link this to the topic of logarithms, why we can't have a log of a negative base as well. It's because some values, if the base is negative, you get a math error depending on what the index is. So with the base of -1, if the power, okay, the index is an integer, we haven't got any issues. That'll work. As soon as the power is something other than an integer, we're going to have certain examples, like say 3/2 or 1.5, for example, where you'll end up getting a math error and it's undefined. Okay, so we don't specify bases that are negative or 0, and we saw why the 0 doesn't work either. Okay, so hopefully that gives you a little bit more clarity and a little bit more reason as to why certain things don't work, or why certain things work, or why they are the way they are. Okay, all the best, and wishing you all the best for your studies.